In the last lesson, we began an implementation of a stack class. In this lesson, we're going to finish the implementation, test our definition, and then move to the next lesson where we'll see how to turn it into a generic stack so that it'll work with multiple data types. So to review, we've created a couple of data members, data store and top, a constructor, a push function, a pop function, and a peek function. The next thing we need to do is write a couple of other functions. For example, count returns the number of items in the stack. So here we're just going to say return top plus 1. Top is always pointing at the next open element, and so adding 1 to that will give us the total number of elements actually stored in the stack. Next thing we need is a clear. So for this clear, we'll write that as a void. Clear simply removes all of the elements from the stack. So we're going to write a simple loop. And here we have to go simply from the 0th element through the top element, top minus 1 plus I. Then we'll simply write data store sub I equal empty string, since we're working with strings here. And then finally, top equals -1 to put it back in the correct position for the first push. Our last function is a Boolean empty. Let's call it isEmpty. This function is used so that we don't accidentally pop an empty array. And this actually could be declared as a private member function. I'm not going to do that so that perhaps user code could work with it, but it is a candidate to be a private member function. Anyway, what we want to check to see is that if top is equal to -1, return true, else return false. And that's the only check we have to make, simply checking to see what the value of top is. That saves a whole lot of time in actually working through the array data store in any manner to determine if there's any elements in the stack or not. So now we're ready to actually test our stack. First thing let's do is let's just compile it and make sure that all of our member functions work correctly. That should be something you always do before you even write test code. And you see right there we have an error, but it's a trivial one. I typed include instead of include. You probably already saw that. Try it again. Of course, nothing happens, but at least the class compiled. So now let's just test it with a few things. We'll put a couple of names on. So we'll call this stack names. Push a couple of names onto the stack. Check the count, like so. We'll use the isEmpty method here. Now we do use pop as a data returning function, but we don't have to actually collect that, so we can work with it just like it is. Let's check the count again. And let's clear it. And then I've already thought of one change we might want to make. For count, let's find it right there. Let's change that. No, let's don't change it because top plus 1 will be fine, because if it's -1, plus 1 will be 0, so that's just fine. So let's clear it and then let's test count again. And let's build and run. So we had 2, we popped off 1, then we had 1, now we have 0. So all of our member functions work correctly. So the class looks like it's defined properly. That's all we're going to do in this lesson to test the ability of the stack class. We know it works, and so what we're going to do in the exercises at the end of the chapter is solve a problem that requires or is enhanced by the use of a stack, and we'll see that at the end of the chapter. Now we're going to move on to the next lesson where we're going to begin to implement a queue class.